Whoa,
Trigonometry comes from the words trigon, which means triangle, and metron, which means measure. Trigonometry is measuring the angles and sides of a triangle. The way trigonometry works is by using law of sines and cosines. The law you use depends on the triangle you're working with. It can be a non-right angle triangle or a right angle triangle. The difference is that the right angle triangle has an angle of 90 degrees and the non-right angle triangle doesn't.
we found Wonderland. You and I got lost in it, and we
The law of sines. A divided by sin of A equals B divided by sin of C, which also equals C divided by sin of C. This law is used for finding out sides. So, to find side A, you have to do the equation. A squared equals B squared plus C squared times 2 times B times C. And then you times that by cosine of A. To find B squared, you have to do A squared plus C squared times 2 times A times C times cosine of A. And to find C, you have to do A squared plus B squared times 2 times A times B times the cosine of C. And now to find out the angle, what you have to do is cosine of A equals B squared plus C squared minus A squared divided by 2 times B times C. To find out the angle and the sides of a right angle triangle, you have to use Pythagoras.
you and I got lost in it, and we pretended.
To find out the sides, you have to remember they are hypotenuse, adjacent, and opposite. To find out hypotenuse, you have to do the square root of A squared, which is adjacent, plus O squared, which is opposite. To find out opposite, you have to do square root of H squared minus A squared. And to find out the adjacent, you have to do the square root of H squared minus opposite squared. You can use the reasons to find out the angles. So, you use so, ka, to. This is to help you remind you of what each reason relates to. So means sin, which divides opposite by hypotenuse. Ka is cosine, and it relates adjacent with hypotenuse. And toa is tan, which relates opposite with adjacent. You have to know which sides you have to be able to do these equations. Now we're going to work on some examples. First, we're going to work an example for the non-right angle triangle. So, if you have a triangle with no right angles, and let's suppose the angles are of one could be 90, the other one of 30, and you're trying to find out one of the sides. And you already know that one of the sides is 20. You have a complete relationship between 40 and 20. So you compare 20 divided by sine of 40 and x, which is the side you want to find out, divided by sine of 30. So this is how you work it out on a calculator.
Never worse, but never better. Eh.
Now we're going to work on an example for a right angle triangle. Remember that the right angle triangles are the ones that have a corner with 90 degrees. Remember, if you have two measurements of two angles, you already know the third, because triangles always inside angles add up to 180 degrees. So let's say you're going to find out x. First, you need to identify each side. X in this case would be hypotenuse. We have also the opposite and adjacent. So what you have to do is finding out hypotenuse. What you have to do is square root of a plus o, which is square root of 30 squared plus 20 squared, which means the square root of 90 plus 40. This results in the square root of 130. And the square root of 130 is 36.05. So hypotenuse is 36.05 meters long. Real life, we had to measure the tallest building in our school. So it was by pairs. One of us stood in front of the building and measured the distance from the standing point to the building. Then the angle from where the person was measured. Also, the person had to be measured, and the distance from the eyes to the top of their head had to be taken away. Our measurements were: we stood 8.5 meters away from the building, and the angle we were looking at the building was of 48 degrees. We had all the angles, but we were missing one side, which would tell us the height of the building. So we labeled each side. We had the hypotenuse, the adjacent, but we had to find out the opposite. So we used the law of SOHCAHTOA. Since this was a right angle triangle, the correct one we had to use was tan, because it related opposite with adjacent. Tan of 48, which was the degrees of our side of the block, equals x, which is our missing side, divided by 8.5, which was the distance from where we measured to the block. That gave us an answer, 1.1106 times 8.5 equals x. So that is 9.4402 equals x. To get more accurate measures, we had to take away the height of the forehead of the one who measured from their eye, so we could get more accurate measurements of how tall the block was according to us. So we did that, and we got a height of 10.89. And this could have been because of lots of things. Mainly because we didn't use the most accurate devices to measure the block. But the real height of the block was of 16 meters. So roughly about turned it out to be. So to find out how wrong we were, we calculated the percentage error, and turns out we were 31.93% off the real measurements. A subject you see at school, but in fact, trigonometry has played an important role and still plays an important role in our everyday lives. maybe not something we see, but for example, if you want to be an architect, trigonometry is key to calculate and to do different process architects do when they're designing or planning a building or just anything in general. Also, the one we found most interesting is that trigonometry is used in digital imaging. And in an era where technology has become so important, digital imaging also has become important because it not only means like TV cartoons. Digital imaging can be used to reconstruct things, to develop different projects. So trigonometry is actually a lot more important than many people might think. And did you know that trigonometry can help measure mountains? Trigonometry can help measure the height of mountains because if enough information is provided, trigonometry makes it easy to measure the height of such humongous natural heights.
I want you to know that it's our time. You and me be the same light. I want you to